This video is for class 9 physics, and we are doing the topic electric current from the chapter current electricity. So here we are discussing about electric current. In our previous video we have already discussed about the source of electric current, DC source, right, that is direct current source. So here also we are trying to understand what is this current means, what is this electric current means. So let us start. We need to understand the current as the rate of flow of electric charge, rate of flow of electric charge. Now the term charge, let us try to understand this term charge. Although you will be doing the charge in your higher classes, probably in class 12, right, but for the time being you just remember charge is the nature acquired by a substance. That means it is one of the property of the substance. Okay, so a substance might be having a positive charge or might be having a negative charge. These are the two kinds of charges, or might be neutral, having no charge. So how does this positive charge or the negative charge comes? When does a body become positive charge or when does it become a negative charge? Let us try to understand. So we have read that when two bodies are rubbed together because of friction, heat, etc., they get charge due to the transfer of electrons from one body to the another body. Now these electrons which gets transferred, okay, they are telling transfer of electrons, these electrons which gets transferred from one object to the another object, right, these electrons are known as actually free electrons. These free electrons are getting transferred, free electrons, okay, free electrons. Let us try to understand this term free electrons a bit. So coming to the term free electrons, so as you all know what atom is, right, and what is the structure of the atom. It consists of a nucleus surrounded by orbits which holds electrons, Now the electrons on the outermost shell, if you remember, are known as valence electrons, right, valence electrons. So when an electron somehow leaves the valence electron, it leaves, right, so that it becomes free. Now these kinds of electrons are known as free electrons, the electrons which leaves the orbit and starts moving freely around the object, okay, inside the object, right. But remember, these electrons cannot leave the object. Now let us consider one object, let us consider one wire, okay. Now this wire is supposed to be made out of many atoms, right, but all the atoms cannot hold their outermost electrons, right, and so some of the electrons will leave their valence shell and starts moving freely, right, and starts moving freely, these electrons, right. So when it starts moving freely, this randomly, okay, in any direction, like this might move in towards your right hand side, this might move towards your leg, this might move towards your head, this might move towards your left hand side, etc. So they have a random motion. Now these kinds of electrons which moves freely under the surface of the sorry, I was about to say water, under the surface of the metal, okay, under the surface of the substance, this kind of electron are known as free electrons. Now when two bodies, okay, suppose body A, right, and there is another body B, okay, are rubbed together, they are rubbed. When they are rubbed together, now what happens is, suppose, okay, there might be high chances that A is losing electrons to B or B is losing electrons to A, depending upon their number of free electrons. Those who have more free electrons, they will tend to lose those free electrons, and those who have less will tend to gain those free electrons. Now suppose A loses 10 electrons, okay, 1 2 3 4 5 6 7 8 9 and one more 10, okay. So A is losing 10 electrons, right, to B, right. Now what happens, now A has deficiency of electrons because the number of protons should be equal to number of electrons now, but these electrons have moved out and have reached to B. Okay, now A loses electrons, A loses electrons, thus becomes positive because it has lost electron, this is positive. Okay, POSI, sorry, let me write it properly, it's positive, 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 right. So A loses electrons, thus becomes positive, whereas B gains electrons because electrons are negative charge, as you will know. So B gains electrons, and thus becomes negative because it has excess of electrons, it has more electrons, right. This is how a body is getting charged, this is how it becomes positive and how it becomes negative. So I hope you have understood till here. Let's go back to our book. Now from our understanding, okay, so body gaining electrons becomes negatively charged while the body losing electrons becomes positively charged. A positively charged body has a deficiency of electrons because it has less number of electrons compared to the protons in it, while a negatively charged body should have excess of electrons, right, because it has gained electrons. So the charges can be made to flow, okay, it can be made to flow between them, that is this positive body and negative body, by a suitable arrangement. For example, if two charged bodies are joined by a metallic wire, the electrons flow from a body having more electrons to the body having less electrons. Okay, the flow of electrons constitutes an electric current, that means it makes the electric current, but how much current, it depends upon the rate of flow of the charges, how fast the charges are moving. So the rate of flow of charges gives the magnitude of the current. Thus current can be defined as the rate of flow of charge across a cross section normal to the direction of the flow of current. So cross section should be normal to the direction of the flow of current. Okay, let us try to understand this. Okay, now we have two bodies, one negatively charged body and one positively charged body. Okay, we have already made them negative and positive by rubbing. Now what we can do is we can join them together with the help of a wire. Okay, I am just zooming, the wire can be a single line, but I am just zooming the wire so that I can show you the flow of the current, right. So here a negatively charged body is joined with a positively charged body with the help of a wire. Now this is wire, okay, this is wire, not this particular thing, right. Now here in this particular wire, now what happens is, as you can see, this has excess of electrons, this has excess of electrons, this has deficiency of electrons. Now the electrons will try to flow from the negatively charged body, these red dots might be electrons, and they are flowing from a negatively charged body towards the positively charged body until unless both of them become neutral. So this flow of electrons, right, let me change the color, this flow of electrons, right, this flow of electrons makes electric current, right, this flow of electrons makes electric current. You can even compare it with the flow of water inside a pipe, okay, from a full tank to an empty tank, right. Now this flow of electrons makes current, okay, it makes current. Now the question comes, how much current, right, how much current, sorry my handwriting is very bad, how much current, right. So to answer this particular question, okay, it's not only the flow of electrons, okay, it can be the flow of positive charges as well. So how much current can be written as the rate of flow of current. How much current is actually the rate of flow of current, sorry, rate, not the current, sorry, not the current, I am so sorry, rate of flow of charge, sorry, that was not current, okay, I am so sorry, right. So it is the rate of flow of charge which gives us the magnitude of current. Rate of flow of charge is known as the magnitude of current, both are same. So magnitude of current, that means how much current is flowing in that particular wire, is given by the how fast the charge is flowing. It is given by how fast the charge is moving, right. So I hope you understood what current is. Now in that particular definition, it was also written that through a cross sectional area, that means rate of flow of charge through what, through the wire, not through the whole wire, only through the cross section of a wire. That means if we, right, if we slice the wire, okay, if we slice the wire, what do we get, right, since all the wires are cylindrical generally, so when we cross section it, we are getting a circle, right. So this becomes a cross sectional area. They are talking about this cross sectional area, right. Now the electrons, right, suppose they are coming out of a screen, these red dots are electrons and they are coming out of the screen. So what is the current? Current is the rate of flow of this particular electrons or the charges which move across the cross section, right, normal, this cross section is normal to the flow of electrons. For example, this is the cross section, here the electrons are moving out, right, the electrons are moving out and they should be making perpendicular with the cross section. So the yellow line shows the cross section, okay, so they are perpendicular, that means they are 90 degree to each other, right. The flow of electrons and the direction of flow of electrons and the cross section, right. Flow of electrons can also be considered as electronic current, we shall discuss that afterwards. So I hope this is clear. Let us go back to our book. So suppose q number of charges, or sorry, the q amount of charge, not number of charges, suppose the q amount of charge flows through the cross section of a conductor. You know, I hope till now you know what is the cross section of a conductor in time t. Then the current has a formula I equals to q upon t. This I represents current, q represents charge and t represents time. Now current is a scalar quantity, they are saying current is a scalar quantity, okay, because should not have direction, the direction, sorry, the direction gets cancelled out, okay, we shall understand when we do the direction of the flow of current, this direction of current, right, this direction of current, sorry, and we can also understand by this factor here, okay, it is scalar quantity because it is the charge, okay, that is number of electrons. Now number of something is a scalar quantity coming across a cross sectional area, which again a scalar quantity, right, again a given time, that is also a scalar quantity. So the current becomes a scalar quantity because the number of charges flowing, okay, or I can say number of charges flowing through a cross sectional area. So the or I can say is the rate of flow, how fast it is, how fast the charges are flowing through a cross sectional area. Now in metals or conductors, current flows due to the movement of electrons. As you all know, protons can't move, while in electrolytes both the positive ions as well as the negative ions can move. An electron carries a negative charge equal to minus E, whose value is 1.6, sorry, in 10 to the power minus 19 coulomb. Here coulomb is the unit of charge, remember, okay, is the electronic charge. If n electrons pass through the cross section, okay, of a conductor in time t, then total charge, that was q if you remember, okay, which is passing through that cross sectional area, okay. Now this total charge q can be written as n into E. Now n represents the number of what? Electrons, and E represents the value of one electron. Thus the current becomes I equals to Q upon T, which also can be now written as Ne upon T. Now Ne is the total charge, that is number of electrons multiplied by the value of one electron, that is 1.6 into 10 to the power minus 19 coulomb. Note, in an electrolyte, as you all know, both positive as well as negative charges, ions can move simultaneously, in fact, in the different directions. So in an electrolyte, the current flows due to the movement of both the positive ions, that is cations, and the negative ions, which are anions. In 1 second, suppose n1 positive ions each carrying a charge of q1 move in one direction, and n2 negative ions carrying a charge q2 is moving towards another direction, that is towards the cathode and anode respectively. The total current will be I equals to n1 plus q1, right? That is total charge, that is q, isn't it? Here q will be, but this is for the positive charge, right? Plus q and n1 number of positive charges, and minus n2 minus q2. Why minus q2? Because they are negative charge, isn't it? Now why do we have minus sign here? The minus sign is here because of the direction of flow of charge. Because of the direction of the flow of charge, they are opposite to each other. Now this minus multiplied by this minus should become a positive, right? So n1 q1 plus n2 q2 is the total amount of current flowing in the electrolyte, because direction of the current is taken positive in the direction of the flow of the positive ions. That means the direction of the current is taken from the positive terminal to the negative terminal, and the negative in the direction in the flow of the negative ions. So let us try to understand this with the help of direction of current. Although it is a scalar quantity, but still we are discussing about the direction of the current. Now why it is a scalar quantity, I think this will be a little bit more helpful. Okay, now direction of current, conventional and electronic. So conventionally the direction of the current is taken from positive in the direction in the flow of the positive charge, that means from the positively charged body to the negatively charged body, right? Why is that? So why it is should be taken from positive to negative? As you all know, protons can't even move. The reason is that this means current. The current was being used by the humans even before the invention of protons and electrons. So at that time we didn't know that protons were static, they cannot move, whereas electrons are the only factors which can move. So direction of the current was taken from positive to negative. Now the rate of flow of electrons in a direction is called electronic current. Therefore we have two kinds of currents here, conventional as well as electronic. So conventional means from positive to negative, whereas electronic means in the direction of the electrons. So these two directions cancel out, hence current becomes a scalar quantity. That's another way to understand why current is a scalar quantity. The conventional current, or simply current, in a direction opposite to the direction of the motion of the electrons, right? Let's try to understand this a bit. So here in this case, as you all can see, flow of electrons is from let this be body A, let this be body B, from A to B, the flow of electrons, right? Now this direction is known as electronic current. Okay, electronic current, whereas the conventional current is taken from positive to the negative terminals. Terminals here means I am talking about the battery, or I can say the positive body to the negative body. Now right now these two directions can cancel out each other, hence current becomes a scalar quantity. We can understand it that way. The better understanding will be done in your higher classes. Okay, so I hope you have understood till here. The direction of the flow of currents also, one is conventional, the other is electronic. Okay, they are just opposite to each other, right? And let us go back to our book. Now the magnitude of conventional current is the rate of flow of total charge, which you have understood, that is Q, isn't it, across the given cross section. The cross section also I hope you have understood. Now next thing is the unit of current. From the relation I equals q upon t, that is from the formula of the current, unit of current should be equal to unit of charge upon unit of time. Now as you all know, the unit of charge which we have discussed is coulomb and the unit of time is second. Both the units are considered in the SI unit. So the SI unit of charge the SI unit of current should be charge upon time, that is second, isn't it? Charge upon time, that is coulomb upon second, right? The SI unit of charge is coulomb and the SI unit of time is second, so the SI unit of current should be coulomb upon second, which is better known as ampere, and it is denoted by symbol capital A. Thus 1 ampere is 1 coulomb upon 1 second. Thus the current is 1 ampere if the rate of flow of charge is 1 coulomb per second. That means 1 coulomb of charge is flowing through a cross sectional area of the wire in 1 second. Since 1 coulomb of charge is carried by 1 upon 1.6 × 10 to the power minus 19 coulomb. Remember here this relationship actually comes from 1 electron's value is given by 1.6 into 10 to the power minus 19 coulomb, if you remember. So 1 coulomb should be equal to this much, isn't it, right? 1 upon 1.6 into 10 to the power minus 19. Thus when we solve this, we shall get 6.25 into 10 to the power 18 electrons, right? So therefore 1 coulomb has this many number of electrons. So therefore if 1 ampere of current has to flow, then 6.25 into 10 to the power 10 to the power 18 electrons should pass through a given cross sectional area in 1 second. Okay, so I hope it is understood. Note, weak current is measured in units milliampere or microampere depending upon the use and the strength of current. 1 milliampere has 10 to the power minus 3 ampere, whereas 1 microampere has 10 to the power minus 6 ampere. So this much for this video. I hope you people have understood. Thank you so much.